Hi everybody, Brad from Triple B, welcome back. And this is the final part of the video of our home storage system. In the last one we showed you what we were doing with the MGZS battery modules, taking them out, putting them into some new storage cases, building our own BMS systems, and then taking all of that and sticking it onto the solar. So we're going to get to part 4 of the video. We're going to pick up where we left off. I think we just got the first battery modules into the box. So we're going to get all that hooked up, running, and then put onto the system. And then you'll finally see all of the system in operation and working as it should be. So let's get into it. Of course, you wouldn't want to drill into your lithium battery, would you? Safety first, Bill. Don't they catch fire if you drill into lithium battery? Oh, they explode. Oh, Jesus Christ. I mean, the minute you even look at lithium battery, everybody knows they explode. Dun dun dun! There's a hole! Okay, so it kind of goes without saying, but the internet does love a good meltdown, so I'm going to say it anyway. Of course, if you're doing anything like this, working on lithium cells, splitting the welded tabs on the top, just please be super careful. You know, we're checking where we're drilling, we're checking where we're cutting, but yeah, just take care, because you don't want any accidents at this stage. Sorry for the noise, as you can imagine. We've got a little Hoover extractor going on there just to pick up any straw. And also we're always being reasonably careful not to actually cut into the cells themselves and just cut through the tab. It's like a root canal. This aluminium is so soft, it's unbelievably soft. What we're going to do now is, so we've just put your M8 hole in there so that we can actually get onto it. I'm going to bend that up and that becomes a tab. And then ultimately when we put the cover back on, we're going to have to make a little small incision in the cover to allow that tab to come through. Going to connect onto there. Here we are a little later. And we've put all of the modules in, all of the BMS wiring has now been done and wired up, and that's routed in and brought round to the front to the BMS boards. We've then put a little DIN rail in on the front here, and that will pick up the 2 breakers that we talked about earlier for the front panel. And we've got the comms cables into the BMS, ready to go onto the front end. And now we're going to start just finishing off a couple of the power cables. So we've put those in the tabs that we folded up earlier. We've got to just finish off those ones. And then we've got the front panel. So we've started to build this up. 2 screens are in, so that'll pick up both battery banks that are inside that and the common battery connections, all of the data comms, some of the dip switches and the LEDs as well. So then that will start building up onto the front end. So we've got some standoffs to pick up the PCBs that come with the BMS kits. So these are the sort of comms and display control. And we just have little standoffs under there to mount them in the right place.
We cheated there. We use hot glue because their
little bit of hot glue
stick out here and they're horrible.
Yeah, so we've again modified the Chinese design with just a little bit of hot glue just to hold them in place. And you can see now the back cut that we did just on the plate to give us the clearance to these, because it's really tight getting all of this in, but it goes. So we're now making some progress, you can see, and then a little later on we will do the final fit, and then we can test the voltages, make sure that all the connections onto these are correct. And as I think we mentioned earlier in the video, really important to understand that we've got all of these in the right place so that we don't risk burning out the resistors on the BMS board. So we'll do some checks on those before we connect them, and then we'll stick the front end in. So a little earlier we showed you building up the BMS wiring, putting that in. Then we've now put in the power cables and we've run some of those up to our breakers. And if you recall from the start of the video, there's two separate battery banks in here, one on this side, one on this side. We've just fully got this one running, and so I've got all the battery cables in up through the breakers, and you can see just down to the left here we've got one of the panels going on the front end, and that panel is actually on, so I'll just show you that. So what we're going to do now is show you the process for checking your wiring to your BMS on the second battery unit. So we've got cables down here, they're all wired in. Before we plug those into the BMS, we're going to take you through the sequence of how we test those. And importantly, what we've got at the back is the battery cable just behind the meter back here is disconnected so that the circuit is broken, so it's therefore totally safe. And we're going to take you through the sequence of checking all of that wiring to ensure that you've done it right before we then plug it all up into the BMS.
Right, we're on DC volts, and generally, which is good practice, is before you make connections, you check to see that you've got the voltage between the connections that you expect. As there should be actually nothing switched on at that end, when I make this connection, there shouldn't be any current flow, so really I'm expecting 0 volts. So we'll just see what we get, and we get 0 volts on the meter. So now I'm pretty confident I can put that connection together and we're not going to have any nasty sparks. If all of a sudden I got sort of 20 or 30 volts, I'd be a little bit concerned as to why, because I'm expecting 0, and that would tend to get you to investigate before you throw the connection together. And again, when working on the system or doing any work at the front, it's always advisable just to remove these link cables between the battery pack at the back, and that gets rid of any power at the front while you're working on the live connections up there, because there is a lot of current available in these batteries, especially with this size cable, and it will be a rather nasty arc and a spark you will get, and that's if you get away with being lucky that way. It can also hurt. Even though it's low voltage at 48 volts, what tends to happen is the arc burns bits of your fingers away and things like that. So yeah, always be cautious.
Not what we're looking for.
And just a voltmeter across the connection before you make the connection on anything big like that can actually save your life. So we've now got power here. So if we come to the front, I'll grab that meter again. We should now have our 48 volts nominal, whatever it's going to be. One or two of these batteries have been used, so they're not fully charged up, so it might be slightly different, but we'll find out now. So that's my neg connection, and I have a positive connection down here, and that tells me we've got 52 volts. Which is in the range I expect to see. So that's filling me with confidence. It's good so far.
So that's our 14 cells.
Yeah.
At broadly 4 point something volt, well nominal 4.2, but probably a bit lower than that right now.
Yeah, they're probably going to be on 3.5. I mean, on the other, we're looking at the other battery packs telling me they're about 3.9 volts ish.
Okay.
So I think this was probably just a little bit lower. Okay. These are the BMS cables. There's a cable going to every cell, and they need to be in the right order. You can see they're numbered 1, 2, 3 and 4. When you plug them into the BMS, they need to be in the correct order, and they do make them different sizes, so it's almost idiot proof. Yeah, mistakes can happen, but the main thing to check is you start off with the first cable, which should be the B0, which is negative. Easy way I can do for checking this is we'll go on here with the...
Well, very handily, the manufacturer of these connectors give you nice little probe points just on the top here.
So we can go
So
in there.
just on those bits there, which means you don't have to go sticking your fingers into terminals or trying to pull the terminals out. You can just use those probe points, which is nice and safe.
Okay, so I'm going to check between there and the battery negative on the BMS, and we've got 0 volts, which is what I'm expecting. I can now move along to the next point, and I've got 3.9 volts, so that's L1. I'm not too concerned about the voltage. What I'm looking at is the voltage is a gradual rise, so 3.9, go to the second cell, that's 7.9, so 2 times 3.9, yeah, that's about right. Third cell, we're 11 to 11.9 volts. Fourth cell, 15.9. We then move on to the next connector, so 15.9 was the last one. 19.
And of course, what this is measuring, to state the obvious, is the incremental value of every additional cell being added to what you're checking.
19, 23, 20, come on, 27, 30. Now there's one which is going to be the same. Yes, the other 30, so we see that one's 30.
So that's cell 8.
And that's the other side of cell 8. On the JK BMS, they didn't used to, but now they take 2 wires to cell 8. And I think it's when they build these in a DIY battery pack, cell 8 is the one linking from one side to the other. But now they seem to take 2 wires to that same cell. So that's 30, so the next one, 34, 37, 41, 44, and then we come to the final 48. This is the final cell here, 52, which
And there's our
corresponds...
52, which correlates to what you measured across the pack.
That's it, and then the final cable, which is the positive, is also 52 because there are 2 cables to that last cell. So that all checks out good, that just incremental. If you suddenly get it reversed, where you find that your cell voltage actually dropped, then you've got a cable in the wrong place. It can be hard work sorting it out in there. In the past, I have actually just dropped the cable out here and moved it to the correct point. Not so much actually getting it wrong, but it's when I've changed the configuration of a battery and I just wanted to move the cables because I've taken cells off. But anyway.
But that tells us now that all that wiring is good. It's going to the cells that we expect it to go to. And we've got no spurious voltages where we shouldn't have them, which means we're now safe to plug all that into the BMS and power it up.
Okay, so before I put that in, what I'll do, that is the 48 volt connection into the BMS for its positive supply for battery pack 2, hence the 2 marks on the cable. So we'll make that so now the BMS is actually now live, and when I start putting these in, we start with number 1, then number 2, 3 and 4, and we bring them up so that it starts with its ground connection, and then as you plug each one in, it keeps everything safe. Okay, so theoretically that should be ready to turn on. That's for number 2, which is this one. So if we press that, we get a bleep, and it looks like it's waking up. On the BMSs, you need to configure them. Once you get to this stage, I've had these already configured before I even fitted them. I've gone through all of mine and configured them. When I received them as a box of 8 of them, I checked every BMS to make sure it was actually working and it would power up on a test battery. So they've all been configured for what I wanted to use. But generally, if you've just taken it out of the box and put it in, it will ask you to configure it, and it will come up and it would show an alarm because it's not being configured. And again with the JK1, you basically use their app. Yeah, so you basically get an app going, and it gives all the settings, and go across to the settings, you end up putting a password in. Okay, we've got our 2 plugs for the outputs, and these are quite nice plugs on the leads, which is pushing.
So they're called an Amphenol Shorelock.
That's it, which we've used. I've used a staggered output for a couple of reasons. If you're stacking these batteries on top of each other, I normally parallel 2 batteries together, so I'll come out of the one plug, one up, one down, and a short piece of cable, and link the battery above. And then, if you can imagine, you've got your plug coming in on the bottom from the battery below. This one will be the cable which will be going off to your panel on the wall or to the buzz bar, and you can either come in over the top or at an angle from the side and around the wall. And the same with the bottom one, that will be the one linking above.
Yeah, well, the great thing about those connectors is they are 360-degree directional.
Yeah. So you can allow that to turn. So if you put them side by side, you can only go up or down. But just offsetting them like this gives you the option of the one cable at the bottom. You can point at any direction. On the back, we've put a copper buzz bar, which links them together. These are 200 amp connectors. Okay, I limit the battery to 125 amps, 125 amp circuit breakers on them. And I tell the BMS that the normal running current is a maximum of 125 amps. These are more purely there for isolation rather than act as a circuit breaker. The BMS is normally a damn sight quicker. If there's a fault, the BMS will normally turn it off. These are just there so you can actually isolate things yourself. But for volt drop, the bigger the cable, the less volt drop is. And in DC, especially at 48 volts and lower voltages, the volt drop is the killer. It's what takes away your efficiencies. So the bigger cable you can go, the better. So next thing for us to do is to take these wires, attach them to the buzz bars, and then this has to go back, and it all gets very, very cosy. And at the same time, we also need to start looking at putting the connectors on for the data comms to go in to these boards.
So this is just about getting everything together, getting it as neat and uncrossed up as possible, so we're not trapping anything. We want to be really careful we're not pinching any, particularly the small cables. You'll see that there's a small little temp sensor. We've got a spare one off the BMS, so we've actually attached that to the side of the breaker. Just a little bit of
one each side
resin glue, 2-pack resin glue, just to hold that in place. Just gives us an extra reading off those. Okay. So quick check.
Theoretically, yeah, we've got our lights running, the running lights are going. So let's.
Oh, that's fun.
Because as well.
Yeah.
There it goes.
That's how you're pushing the button.
That's how you're pressing the button, yeah. Telling it to turn off.
She's a little bit tight, boy.
£70 So that puts power onto there, and that will power them. Oh, 80 amps. 99, 100.
Yeah, she just broke 100 there.
That's gone into current limit. See, she's gone into alarm.
Yeah.
So if we look at that, overcurrent protection. So what that will be doing now, it'll be charging at 10 amps. So with the JK BMS, if it goes into overcurrent, it sees the overcurrent and then it automatically puts a 10 amp charge on it. So that's limited the charge current to 10 amps. And I think it's about every 3 minutes it will try to go back to normal. And if the current is too high, it will then go back to 10 amps. And you can set this.
And what that's doing now is essentially balancing between those two packs.
Yeah.
Is this trying to drag out the excess power out of one and put it into the other?
The 54 volts now trying to charge the one at 51. And you can see that's an alarm because it's saying I'm doing current protection on the charge because the charge current was too high. I've set these, I think, to have a charge current of only about 35 amps, maybe 40 amps maximum.
Yeah, and that's configurable, isn't it? In the software, you can basically tell it how up to the limit of the BMS.
That's it.
You can tell it how much you want it, how many beans you want it to give it.
It's now interesting. You see, we've gone out of alarm. Just that short burst of current, and she's now gone out of alarm, and she's just charging now at about 10 amps itself. So she's taken the alarm out.
Happy days.
So that's proved that the overcurrent works.
And what do these give us now in kilowatt hours?
This should give me just under 10 kilowatt hour for both batteries in there.
So let's talk about cost. So you can buy ready-made home power packs, home batteries, whatever you want to call them. You can buy them off the shelf now.
5 kilowatts, dependent on the make and the brand, can be sort of anything up to around about 2k, but I think you see them now about 1500. And then by the time you're looking for a 10 kilowatt, you're probably looking more 2,000, 2.5.
So 2.5 grand, right, for an unknown system that you've then got to figure out. Now, okay, in reality, you know, we've spent 2 grand. Well, we replaced the battery in the car.
Replace the battery
because that needed to be replaced.
Change,
Come on, mate, that had to happen. So I don't want to say it's a free battery because it's not.
No, there's a cost.
But in essence, it sort of is a free battery because it's second life.
Well, if you look at the second battery I bought, so the second battery I paid 2 grand for.
Yeah.
So if
for the larger cells.
Yeah. So I paid 2 grand for that battery. So I actually got that battery cheaper than this one.
Yeah.
But that one wasn't for the car. That then gave me 6 modules, because they're a bigger module.
Yeah.
It gave me 6 modules, and each module is supposedly 11 kilowatt hour. I then used the same box.
So we said box is about 150 quid landed, isn't it?
50 quid by the time I get the box. 150 quid for the BMS.
Yeah, so 300 quid of BMS in this one.
Yeah. The other battery worked out about £333 a battery.
Yeah.
So your box, so you're looking at £600.
You've then got 50 quid of cable, probably 50 quid of eyelets for decent quality cable lugs, bit of heat shrink, things like that. So let's call it another 100 quid of sundries.
Bits.
Yeah. So we're up to now 750.
750
for an 11 kilowatt hour battery pack.
Yeah.
But in essence, that's £1,000 cheaper than you would buy the absolute cheapest one online that you could do.
Yeah.
And you're getting quality battery cells that you know where they've come from. In essence, the more you make of these, the cheaper it gets, because if you do end up spending 2 grand on a second life MG battery pack, you can then go and make 6 modules like this and have
down the bottom
70 kilowatt hours of battery storage. Yeah. And that leads me nicely on to the plant room. 1 or 2 inverters on the wall. But more importantly, what I wanted to show you was these cases. Here's a few we made earlier. 1 or 2. And all of those have been made out of the modules that we've removed from the two MG battery packs, both the 44 kilowatt one and the 74 kilowatt. And if we just spin around, here we are. So let me just zoom out and you can see a bit better. Right, so we start at the top. So just as you saw before, now these ones where you see the single screens, these are the ones using the larger pack modules, because there's only one battery bank. It's only one battery module as such in here. One of the battery modules out of the larger pack in each one of these, hence why there's only one screen, one breaker, one set of comms, etc. But the HV connections are just the same, and we've just daisy chained them down, as you can see. Again, another single one there, another single one, another single one. And then these two at the bottom are double ones like we've just built up using the original battery pack modules that were the ones removed out of the car.
And you'll see what's the discharge current, what we're pulling.
So 1.8 amps there.
1.8 amps, that's running the house at the moment. So you can see.
So sat at just over 50 volts. So 50.8, 50.7, 50.7. The cat is tapping my head. What are you doing?
She wants some fuss.
What are you doing? Hello? I've got a bit more kit there. Underneath this is a 20 kVA diesel generator as another backup system. That lives under that box. And then these are all of the solar inverters taking power from the panels that we've got around the house. But in essence, what this is giving us is a completely isolated off-grid system. There's a changeover switch in there as well, I should mention. So all of the batteries ultimately end up going into here. There's a great big breaker and changeover. And you can see some big cables going that way as well. But this allows complete isolation from the grid, so it gets charged up by solar in the day, stored into these. It can then be pulled out as required by the house. It can be pulled out by your electric cars, by those two inverters. So that one and that one.
In the house at the moment.
So 0.7 kilowatts there with 700 watts.
Yeah, that's the house.
Out the battery, so not a lot really.
But those two work together in parallel, so if I put the car on to charge, they will charge the car from these batteries.
So yeah, again, so we can charge both of your electric cars using these batteries if required from energy stored by the solar. There we go. And that is what we've been up to as second use life for those MG batteries. Now these all replaced a very large bank of lead acid batteries that were doing the same job but at much less capacity, less storage capacity, purely because of the advantages or disadvantages of lead acid over lithium. So now we've replaced with these, and this is going to be broadly what, 100 kilowatt hours, just under?
Well, each one's 10 kilowatts, so we've got 60 here. We've got another 3 modules. We just built one. There's another 2 more to go. So
yeah, so we'll have 90-ish kilowatt hours, which will be plenty.
The advantage over the lead acid batteries is these will absorb as much energy as you can throw at them. Where the lead acid batteries, as the lead acid batteries come up to the top and got near the top of getting charged, they would drop down to a much lower charge rate, and then you started throwing solar energy away. Where these will just keep swallowing the current, as much current as you can give them, right up to the last little bit of charge, you know, up to the last couple of percentage of charge level. So these will just take everything that the solar system can generate and just soak it all up, and we don't have to export anything to the grid.
Well, that's it. That's the end of our little series. Thanks for joining us as we turned an MGZS old EV battery into a home storage power system. We hope you liked it. We hope you found it interesting. Please do leave your comments and thoughts below. Don't forget to like and subscribe. Click that bell. It really helps us out. And we'll see you on the next one. Bye for now.